Hello, this is a video to help you work through the doubling time, also known as generation time, calculations from a bacterial growth curve experiment. So very frequently in this type of question, you will receive a table of data that says, you've done a growth curve experiment, you've taken samples of the bacterial population at various times, and you have counted them, and here are the results you got. So you'll get something like a table of time versus bacteria number that I've given you here, and you'll be asked to calculate the doubling time of that organism based on this data. So the first thing that you want to do is plot the data. So bacteria number versus time. And you want to go ahead and plot out your data. Let's change the color here to make it more visible. Okay, so at time 0, we had 150. At time 30 minutes, we had 200. At 60 minutes, we had 400. At 90 minutes, we had 800. At 120 minutes, we had 1,000. And if we kept going, we would see the entire bacterial growth curve, all 4 phases. But what we care about, the part that we are focused on, is the log or exponential part of the growth phase. Why? Because that's the part where it's growing the fastest. Doubling time is, if given a perfect situation, how fast can these bacteria possibly grow? So that's the only part of the growth curve that we care about, because that's the part where it's pedal to the metal, going as fast as it can. So I've plotted my data. Let's kind of connect these points. Sorry, not the prettiest connection, but you get the idea. Let's try again here. Steady your hand. There we go. Okay, and what will happen if we keep going is you'll see the plateau, and then it will begin to drop down, and you'll go into stationary phase and death phase. But we are focused on the exponential, the part where it's growing the fastest. Okay, how do we know we're in the exponential phase? Because that's the part where the line starts straightening out. And when we look at the data, we can see that from one time point to the next, we are at least doubling one time. So doubling time, remember, definition is the fastest these organisms can double. So if you're going to determine what is the doubling time, you're going to look in the log phase. And I always say to take 2 points that you feel are comfortably in the log phase, to where when you look at the numbers, you can see that it's doubled. Has it doubled there? No, because 150 times 2 would be 300. So we haven't fully doubled yet. Is that a doubling point from 200 to 400? Yes, it's doubled. So we're starting to increase. 400 to 800, yep, we're still increasing, at least doubling. 800 to 1,000, did we double? No. So here, we started slow, we're going fast, we're starting to slow down. So these points right through here from 30 to 60 represent our log phase. That's where we're slowing fast, slowing again. Okay, so you take 2 points that you like. It doesn't matter if you take the first and the last or the middle ones. You'll all get the same data. We'll just say 30 minutes and 60 minutes. Okay, so at time 30 minutes, you had 200. At time 60 minutes, you had 400. How many times did this double? Well, 200 times 2 is 400, right? So if every one of those cells doubled themselves, you'd have 400. So that was one doubling event. And how long did it take for that one doubling event to happen? 30 minutes. So in 30 minutes, it doubled one time. Therefore, the doubling time is 30 minutes. Ta-da! If you would have chosen 400 to 800, you would have gotten the same thing. What if we would have chosen the end points of our log phase here? So instead of choosing 60 minutes, what if we would have done 30 minutes and 90 minutes? Okay, so at 30 minutes we had 200. At 90 minutes we had 800. So how many times did we double? Well, 200 times 2 is 400. So that's one doubling event. 400 times 2 is 800. So that's another doubling event. So in the 60 minutes that we're looking at, we went through 1, 2 doublings. Therefore, if you divide in the amount of time it took to double one time was 30 minutes. So if you gave these cells an entire hour, they were able to do it twice. Okay, so that's the concept. What if we changed it up a little bit? Let's just change the color a little for visual sake. Okay, so what if we changed it up here, and instead of 400, I'm just going to erase the rest of this. Okay, so instead of going 200 to 400 in our 30 minutes, what if we went 200 to, okay, clean it up a little here. So what if in our 30-minute window, instead of at 30 minutes we have 200, at 60 minutes, what if we had 800 there? So if we went at 60 minutes, what if we had 800? So at 30 minutes we have 200, at 60 minutes we have 800. Okay, same exact idea. How many times did we double? 200 doubled would be 400, so that's one event. 400 doubled would be 800, so that's another doubling event. So we've doubled 2 times in how long? 30 minutes. So how long did it take for it to double a single time? Well, you divide the time by the number of times that it doubled. So for it to double one time, it took 15 minutes. Therefore, the doubling time for that organism would be 15 minutes. Okay, so any variations of the numbers, you do the same basic idea. The big thing is to make sure you've picked 2 points within the log phase. And in this class, I'll always give you nice, clean numbers. So if you're getting decimal points, if you're feeling the need to pull out a calculator, then you're wrong. Okay, it should be nice, clean integers, whole numbers for our class. In the real world, it is not. The numbers are much more complex. You get things like 7 minutes and 42 seconds and all of these kind of strange things. But for our class, we'll have nice, clean numbers for you to learn on.